Hey, your honor, stick around to the end of the video where we're going to take essentially this whole code and condense it down to everything you see up on the screen right now. So sit back, relax, be your favorite snack, and let's get started. Hey Islanders, welcome back to another episode. For those of you who are brand new to the community, my name is William McKeon and you're watching Island Robotics, where we're using Python to learn applications of machine learning and artificial intelligence through demonstration. For instance, today's video is going to be about data correlation, an important part of the data preprocessing stage. What is data correlation? Well, data correlation means that two pieces of data have a high linear relationship, where if one increases linearly, the other one will also increase linearly or decrease linearly. It's really something that can cause a lot of issues with really powerful machine learning and artificial intelligence models. So not only do we really have to identify data correlations, but we also have to be able to correct those data correlations, which is what we're going to be going over in today's video. There are many ways to actually identify these data correlations. For instance, we're going to start off with standard correlation coefficient for each one of our columns. Now you can really think of this as the correlation score or the correlation matrix, whichever one makes sense for you, go with that. But what we're going to do is actually switch over to a script where we will get more in depth on how to actually implement this correlation matrix. The script we have right behind us is going to be how we're going to be able to use this correlation, well, how we're going to be able to get the correlation scores. Now, luckily for us, and really just like how it's really been throughout this whole series of the data preprocessing series, is that we're going to be able to use the pandas module to make our lives a lot easier, because the pandas module actually has a method within it that's going to be outputting some sort of it's going to be outputting the correlation matrix for each one of our columns. Now, the way to actually call upon this method, first of all, we have to import the pandas module, which is exactly what we're doing right here, by saying import pandas as PD, and then we have to have some sort of pandas data frame within our script. Now, when we say data equals pd.readcsv, what we're actually doing is taking that CSV file and importing it as a pandas data frame. Now, notice that it's not just housing.csv, but a whole file location of where housing.csv is. Now, if housing.csv was within this file location, it'd be perfectly fine to just call upon housing.csv. Now, since housing.csv is actually within a whole nother file directory, we have to actually call upon the exact path to that file directory, which is what's going on right there. Once we have created our pandas data frame, what we're going to be doing next is actually creating our correlation matrix, which is going to be really two lines. And the first line is going to be core equals data.core. It's as simple as that to be calling upon the correlation method within pandas. Now, the next line is actually going to be how we're going to populate this correlation matrix. There's just one thing we have to go over real quick before we actually populate this correlation matrix, and that is that we're going to be picking one column that's going to get compared against all the other columns within our data set. And really what you want to do first, before picking any of the other columns we get compared against the other columns, is by first picking your attribute column. We can also consider this column as the Y column that you'll be using to train and test your machine learning and artificial intelligence model. All right. So really, with all that being said, how we're going to be implementing what I'm talking about is by actually coming over to our script, and the very first thing we're going to really want to do is actually make sure that the column that we're calling upon is the correct column. And really the reason being is, well, when I say correct column, I'm talking about spelling wise, that the column that we add into our brackets is exactly spelled the same way as the column that's within our data set. So the way that we're going to actually be able to do this is just by saying print, I got to come up to here, print data.columns. Now I'm going to run this. The column that I specifically want to look at is going to be the median house value. The reason being is because, like I was saying just a couple of seconds ago, the median house value is actually going to be the attribute for our machine learning model. So when we just come over to here, copy U, Command C. Now to actually be able to get this correlation, well, the correlation matrix for the median house value, what we're going to do is comment this out, and then we're going to come over here and we're going to say print core, and we're going to pass in the argument of, well, the column name of the column that we just copied, which is the median house value. So quotations, and then we're going to also want our values to be sorted in a very specific way, where we see the highest to the least values. So we're going to say dot sort values, and then within the parentheses, we're going to set ascending equal to false. Now, when I run this, we're going to be getting a correlation matrix that looks a lot like this. Now, let me make it so that all of you can really see it, and we can go over what is going on within this correlation matrix. So we have this matrix right here that, by the power of editing, I was able to somehow magically make it come right here. Now, honestly, what are the scores that we're looking at? Well, these scores are actually going to vary from -1 and 1. 1 meaning as median housing value increases, that column will have a linear relationship where it will also increase as well. Now, if median housing value increases as well and the correlation score is actually a -1, that means that that has a negative linear relationship. Therefore, the value of that column is actually going to decrease in response to the increase of the median housing value. So really what we want is a perfect score of 0. Now, we don't live in a perfect world, so therefore we have to make a couple of exceptions. What I mean by that is really what we're looking for is a score between -0.5 and +0.5. Now, in the circumstance of median income, what we want to actually do is kind of keep an eye on it, because 0.68 is only about 0.18 over what I would consider in the okay realm. However, it's not so far out there that we really should consider combining them automatically. What I really want to do is hold off on that until we start populating errors inside of our model. Therefore, when we do, what we're going to want to do is actually come back to this step and consider merging them. Now, there's really not anything too interesting going on within this correlation matrix. So what I want to do actually is looking at another column, total bedrooms. This column, I've done a little bit of research into all the different columns, looking at their correlation scores. And total bedrooms has a lot of different examples on when you really should consider it, making some sort of action in correcting this high data correlation. And the way that we're going to actually be able to look at the total bedrooms is by coming over to here, line 6, see where there's median house value. What we're going to do is highlight this, and we're going to type in total bedrooms. Now, when I run this, what we're going to do is get the same exact correlation matrix we just had. Now, what I'm going to do is actually make this a lot bigger, and we're going to go over a lot of the red flags that you all should be seeing right about now. What you're all viewing up on the screen right now is the correlation matrix for the total bedrooms column. And really what we want to take away from this is that households, population, and total rooms has a high correlation relationship with the total bedrooms column. That's going to want us to do a further investigation on really what should we do with those columns. Should we consider correcting them, or should we leave them alone and just let them be? Honestly, it's going to come down to your instincts on what is going on with your data set. There's going to be some circumstance where we do further investigations on those columns or those pieces of data, and it turns out what we're going to want to do is just do nothing at all. So when we go on to the next step, which is taking all the information we got from those correlation matrices and then turning them into a scatter plot so that we can have a further in-depth understanding of what is going on within our data set and what is the relationship of our columns with each other. Honestly, all these questions have to be answered so that we can properly make a decision on what we should do with each one of these high correlation relationships and what has to be done in order for us to actually create a successful machine learning model. And that's really going to start with data visualization. We're over here back at this Python script. We're going to come over to a new line, preferably somewhere near all the other modules that you've imported. I'm going to say from pandas.plotting import scatter matrix. Scatter matrix is going to be doing all the heavy lifting for this data visualization. Now, in order to actually see this figure or this plot, what we're going to want to do is actually call upon the matplotlibs.pyplot. So I'm going to hit enter again, and we're going to say, import matplotlib.pyplot as plt. Once that's all set and ready to go, the next thing we're going to want to do is actually create an attributes list. We only want to be dealing with a certain portion of the data set. We don't want to be dealing with the whole data set creating the scatter matrix, because the scatter matrix is honestly going to be really big if we do that. So what we want to do actually is all of the values that we talked about recently in this video that it's going to essentially be a problem child for us is what we want to primarily be focused on. Now, in order to actually do that, we have to create a list with all those column names. Easily for us, all we have to actually do is come over to here. We're going to say print data.columns. When I run this code, what's going to happen is that we're going to get a list of all the column names within our data set. This is where the easy part comes in, because all we're going to really do is just a bunch of copy and paste. So what I'm going to do is come over to my Python output, and I'm going to look for the very first time one of the columns that we're looking at's name come up. Luckily for us, it's total rooms right here, so I'm just going to highlight total rooms all the way to median house value. Now I'm going to copy that, and then comment this out, and then we're going to code to a brand new line. We're going to say attributes equals, and we're going to create a list. So brackets, and then copy all that in. It's going to come out a little funky, so just do back, enter, back. Now we have all the attributes that we want to actually be specifying to view within our scatter matrix. Now the next thing we actually have to do is create our scatter matrix, and it's actually very simple to create our scatter matrix. All we have to do is come to a brand new line, and we're going to say scatter matrix data brackets attributes, and we also have to specify the figure size. So we're going to do a comma, fig size, let's just say 20 by 15. Oh, no. Now, we have the scatter matrix all set and ready to go. If you were to hit run right now, nothing at all would happen. The reason being is because we don't have plt.show. So let's just add that right now. plt.show. And now when we do Control R, we're going to be getting our scatter matrix. It's a little slow sometimes, but here we go right here. Now, what's going to happen real quick is that notice how all these there's bar graphs inside of our scatter matrix. The reason being is because those are all inferences where the same columns are being compared for correlation. So what Pandas actually has done is decided that it's easier for us and more digestible for us to actually see that information as a bar graph. Not only that, when evaluating this data set, we're going to see a lot of crazy looking plots, as you all can see up on the little corner right here. Now, what's going to happen right now is that there's going to be two circles up on the screen. They're going to be circling two plots. Those two plots are actually the median housing value and the median income. Those two plots that are circled are the same exact plot, except the X and the Y are flipped around. Now, notice it's not really linear in a way that some of the other plots you see up on the screen right now are. However, it's kind of got a little bit of a blob motion going on. Not too much really to worry about. However, if you're going to notice, the other two plots that are circled right now are actually the total bedrooms and the household. Notice how that plot is basically a line plot. Not a scatter plot, but a line plot. So therefore, we're really going to want to actually, first of all, enhance the image of this by using the same class that we created in the last video, data visualization, to make a bigger plot of that one scatter plot. And the way that we're going to be able to call upon this data visualization class is just coming into our script. We're going to say from data visualization import, oh, I don't want caps lock, data visualization. Now what I also want to do is actually comment all of this out. No, that's not what I want. Comment this out, and we're going to say plot equals data visualization, data equals data, type of plot equals scatter, columns values for X, we're going to say households, and then for columns values for Y, we're going to say total bedrooms. Now we have all that set up, so the last thing we really have to do to automate all this, we're going to say plot.driver. Now let's run it and see what we get. Really, this plot is not really, to me, it looks more like a line plot more than a scatter plot. And really what we're going to want to do is actually make some corrections between total bedrooms and households, as well as a lot of the other columns that had a high data correlation relationship with total bedrooms. So what we're going to do in order to actually do that is actually combining those columns into one column. So what I mean by that is we're going to take total bedrooms and household, that rise and run from that scatter plot we just looked at, and combine it into one column, as well as total bedrooms and total rooms, combine it into one plot. I'm making all this sound a lot more complicated than it really is. So what we're going to actually do is by coming over the script, and what we're going to say actually is we're going to be creating a brand new column inside of data. So we're going to say data at, let's call this total rooms per household. So total rooms per household. Now it's going to equal data at total room, no, not bedrooms, I want total rooms over data at households. Now I'm going to do this a few other times, but it's going to be the same exact concept. So instead of boring you with that, what's going to happen is we got the final code of this part of it done, where we're going to be combining populations in household to create populations per household, total bedrooms and total rooms to create total bedrooms per total room. Now what we have to do, since we create those brand new columns, and what you're going to see on line 19 all the way to 22, is we actually have to drop the old column so that there is no errors that will continue on from here on out. So that's really what those 3 lines are doing. Now what we also have to do is also check the correlation scores again with the correlation matrix. If we were just to run this line right here, what we would actually get is the old values before we actually deleted those columns. So now what we have to do is actually we're going to say core equals data.core. So we're going to reinitialize core, and then we're going to print those scores again, giving us what looks like this right here, where as you all can see, the correlation values for total rooms per household is actually very low. There are very few that actually even come close to having a somewhat high correlation value. I mean, total bedrooms per total I spelled that wrong. Total bedrooms per total bedrooms, which is supposed to be total rooms per total bedrooms, is actually negative 0.41. That is really good. That is within the realm of what I feel comfortable to actually proceed on with. Alright, so this is actually my very favorite part of all my videos, where we take everything we just learned, turn into one amazing class, and therefore we're going to be able to allow us to use this tool over and over and over. So therefore we're not pulling our hairs out, having programmers headache. And really this class is going to start off very simply by importing all the modules we're going to be needing in today's class. For instance, pandas.plotting module, the matplotlib module, and then the module that we created in the last video is going to be the data visualization module that you're all seeing being written right behind me. Now inside of the data correlation class, really one input argument, df, which is going to be shorthand for data frame, as well as this is the init method is where we're going to initialize many of the variables that we're going to be reusing over and over throughout the rest of our class. Now the 2 methods you're seeing being developed right behind me are actually 2 helper methods. Pretty much we went over pretty in depth on what they do in the data visualization video, because those 2 classes actually come from the data visualization class, and honestly I copied and pasted them as well as added some tweaks to it to make it more robust for this. Now going into the very first method for the data correlation class is going to be, well, I really shouldn't say that this is going to be our first method of the data correlation class. Really this is going to be the 3rd method. However, the other 2 that I just mentioned are the really helper methods for our class to allow this class to be able to function properly. This is going to be the very first class that we're actually going to be diving deep into the correlation scores of each one of our columns. Now what you're noticing over here on line 29 Command Z, did not mean to do that. What you're seeing from line 29 all the way to line 41 is that this method is going to dive into our data set. It's going to find every correlation score that's either greater than or equal to 0.5 or less than or equal to negative 0.5. If a correlation score does exist within our data set for that specific column compared to another column, it's going to be populated within our high correlation list. Therefore, when we hit this part right here, we're going to be able to evaluate, see which pieces of data have high correlations within each other. Therefore, allowing us to be able to go on to the next method, which is going to be looking at core. Now, within this method, it's actually all user driven. So the user doesn't really have to import anything, because once you call upon this method within this class, it's going to say, hey, these are all the column names within your data set. Which columns would you like to create a scatter matrix from pandas.plotting method? Now, once that's created and you're actually able to view that data from the scatter matrix, you're also able to, once you X out of that figure, go on to actually enlarging one of those scatter plots, allowing you to really have the ability and the simplicity to actually be able to visualize your correlation matrices, kind of instead of just writing out that whole code, and it's very simply identified within this one method. Now, the last method of this whole class is probably going to look extremely complicated, but I assure you it is nowhere near as complicated as you may think. It's much like the looking at core, and it's going to be the combine method that we have right here. Now, I just want to real quick scroll through how big this method is. And it's actually the least complicated method out of all of the methods that we talked about in today's video. And really what this method is doing is, remember when we had all of our information from our data correlation, a way to actually correct your data correlation is by combining those two columns into one column. So therefore, once you're able to figure out all that information, you can call upon this method within this class. It's going to combine the columns that you wish to combine, and then once you're done with that, it's going to delete those columns from your data set. But before you actually are able to really use this data set, it's going to ask you to really view the correlation matrix again for your data set. I highly suggest you hit yes when it does, because therefore it's going to allow you to really have an idea of what is going on within the new columns of your data set, which ones now have a high correlation, and if you should actually consider combining them as well. And then really once you're done, you have the choice to actually save the new data frame within your code, and it's going to be whatever the name of the instance that you create for this class, .df, therefore allowing you to actually be able to use it within your machine learning model and not really have to worry about all that's going on. However, I just want to point out that there's going to be one thing you have to keep, is that if you have an object type column in your original data set, it's no longer going to be part of the new data set, which brings me to my next point, is that next video what we're going to be doing is taking all that text, which is essentially human language, and converting it into a format that our machine learning and artificial intelligence models can understand, essentially machine learning language. If you want to get your hands on this script as well as this tool, go ahead and check out the GitHub link down in the description bar down below, or go to github.com/islanderrobotics/data correlation, or check out the link that's right on the screen right here. If you're not yet subscribed, please do consider becoming part of the Islander community, where we believe in using Python to learn applications of machine learning and artificial intelligence through demonstration. If you enjoyed today's video, please do consider hitting that like button, and I'll see you all in the next video. Bye, happy coding!